How y'all doing? This is Mr. Smith from Advanced Math Tutors, and today we're going to be looking at solving some equations you've come across in pre-calculus. The worksheet we're going to be working with can be found at advancedmathtutors.com/online_lessons, and just to show you real quick, you can go to this website here, and you're going to find it here, Solving Equations Part 1. Click on that, it's a PDF, and it opens right up. So you can try these if you want, or you can just watch me do them. Either way, hopefully this helps you out a little bit. We're not gonna do them all here. I'm gonna start with number 1, and we'll do 3 and 5, and then we'll move down the list here. So we're gonna start with exponential equations. So number 1, 1.06x equals 4.1. Let's put this on freehand. 1.06 to the x, equals 4.1. Now, this is an exponential equation because we've got this exponent where the variable is. Now, we need to get him down, and the way you do that is you take natural log of both sides here. So we're going to take ln of this entire side and squeeze in ln of this side. Now, ln of 4.1 is just some number. It's a decimal. I'm not going to find out what it is. I'm going to leave it as ln of 4.1. And when I take ln of this side over here, now we can bring this x down to the front, which is what natural logs are good for here. They help us out. So we get x times the natural log of 1.06, which is, again, it's just some number. It doesn't matter what it is, equals ln of 4.1. And since we want x here, we have x times this number, ln 1.06. I don't care what number it is, really. We just divide both sides by it, and we're going to get ln 4.1 divided by ln 1.06. Nothing tricky. There you go. There's your answer. If you need to turn it into a decimal so you know exactly what number it is, grab a calculator and just do that division. Alright, our log rules don't really help us simplify this down either. Remember, if you're doing a log of and you're subtracting things, what's this rule here? You have log of x minus log of y. You can turn that into log of x over y. But you cannot do anything when it's two logs being divided. That's just what it is. Okay, let's take a look at number 3. 40 times 1/2 to the x over 3 equals 10. Let's check this down. 40 times 1/2 x over 3 is equal to 10. Same situation. You got your variables in the exponent, so you're never going to have to take a natural log to get him down. Before you do that, though, you don't want to take natural log of this entire side. You want to get rid of that 40 first. So we're going to divide both sides by 4. No biggie. And that's going to leave us with 1/2. Use your parentheses there. It's 1/2 to the x over 3 is equal to 10 over 40 is a 4. And now we want to get the exponent down, and the only way to do that is to take natural log of the entire side. You can do it to one side, you gotta do it to the other side. Now we're allowed to bring the exponent down, so it's going to turn into x over 3 times the ln of 1/2 equals the ln of 1/4. Cool. I'm just going to drag this up here. Same thing's going on. We need to get rid of the ln of 1/2 and this 3. So we'll divide by ln of 1/2 on both sides, and we're going to multiply by 3. So we're going to get ln of 1/4, which was there originally, divided by ln of 1/2. We're going to multiply the whole thing by 3, which is the same as just putting that 3 out there. Okay. So let's take a look at number 5, I believe. 200 over 5 plus e to the negative x equals 6. Clear this out. 200 over 5 plus e to the negative is equal to 6. Now we've got an exponent with a variable, but it's in the denominator. And anytime your variable is in the denominator and you want to solve for them, you got to multiply through both sides by what that denominator is. You don't really want to deal with a fraction, so multiply through by the common denominator. In this case, we're going to multiply through. It's going to cancel on this side over here, so we're going to get 200. And this is just going to be 6 times 5 plus e to the negative. So we're going to distribute that 6. It's going to give us 30 plus 6e to the negative x. And we want to get x by itself, so we're going to have to take natural log here again. Well, you can take log of any base. I always choose natural log. You can do log base 10 if you like that better. And that's going to allow us to get this exponent down, but we can't do that until it's just e to the negative x. We got to get rid of 30 and the 6. So we're going to do minus 30, which leaves us with 170. 6 times e to the negative x. And then we're going to divide everything by 6. So it's going to give us 170 over 6 equals e to the negative x. And we can simplify this fraction here. 170 over 6, 2 goes into both of those guys. So that's going to become 85 over 3 is equal to e to the negative x. And again, we want to get that exponent down, so we're going to natural log both sides. Hello, darling. This is my wife, everybody. Say hi, wife. Okay. What's up? I'm doing some math for fun. You know I love this. You can bring the exponent down now, so it's negative x times ln of e. But ln of e is just 1. So this side is just negative x times 1. And this is ln right there. What's up, baby? Now we're going to get rid of this negative x, so the negative 1, so we're going to divide by negative 1, which makes it ln of 85 over 3 equals x. Alright. Moving on here, we are going to work with, let's do number 8. ln x plus 3 equals 2. Alright, when you got two natural logs, you need to combine them into one using our rules here. ln of something plus ln of something else means we're allowed to make it one natural log of those two things being multiplied. Like this guy. And it's going to equal 2. And you can simplify that down to this. And now, logs are the opposite of exponentials. We have a log here, and the way we're going to get rid of the natural log, we got to get this x, so we're going to rewrite it exponentially. So this says ln is really base e, even though you don't write it. This says e to the second power is equal to x squared plus 3x. And that's just a quadratic. E squared is just some number. It doesn't matter what it is. We're going to get 0 is equal to x squared plus 3x minus e squared. And usually you try to factor a quadratic, but once you see an e in there, we don't really care about factoring. Let's just do the quadratic formula. Do negative b, which is negative 3, plus or minus the square root of b squared, which is 9, minus 4 times a times c, which is negative e squared, just some weird number, divided by 2a, which is 2 times 1. And your final answer, the best you can do with this without a calculator, is negative 3 plus or minus the square root of 9 plus 4e squared, because the negative and the minus make a positive, divided by 2. Oh, it was a terrible one. There, much better. Okay, moving on. That was number 8. We're going to try number 9 here. ln x plus 1 minus ln of x equals 1. So let's clear this out. Very similar situation. We've got two natural logs here. We got to combine them down into one and then rewrite exponentially. So when there's a minus here, we can create or rewrite it as one natural log, and instead of multiplying, we're dividing. That's what happens when you subtract two natural logs. They become 1 with a division inside. And that equals 1. Now, our variables are inside of a log. We don't want that, so we got to write it exponentially. Remember, ln is base e, so this says e to the first power is equal to x plus 1 over x. Now we're trying to solve for x here, and we have a fraction with x in the denominator. We do not want x in the denominator if we're trying to solve for it. So multiply through the equation by x. That's going to cancel it on this side and give you e times x on this side. So you're going to have e times x is equal to x plus 1. There you go. Now we're trying to isolate x, so I'm going to get them all on one side. I'm going to move this x over to here by subtracting it. So we get e to the x minus x equals 1. And now, if this e is just a number, we can really turn it into a decimal and subtract off 1x and get a decimal number here and divide. That's great. If you don't have a calculator, we don't want to round e, so what we're going to do is factor out an x, because we're trying to get down to 1x. If you factor an x off of that side, let's draw a line here so these separate. If you factor an x off of this side, you're going to get e minus 1, and that equals 1. Now, e minus 1, again, is just a number, so we are going to, I know I'm getting annoying here, I keep saying that, but don't freak out if you see an e or a pi or anything. You're going to divide by e minus 1, and that's going to cancel out over here. X is equal to 1 over e minus 1. And again, you can just drop it into a calculator if you want, but that's a good enough answer for most calculus teachers. Okay, that was number 9. Now we're going to take a quick look at 11 and 13. So 11 says 2 minus 5 over 2a equals 2a over a plus 1. We might have to come back to that. 2 minus 5 over 2a. So 2 minus 5 over 2a is equal to 2a over a plus 1. Alright, right off the bat, you want to solve for a. You've got a's in the denominators of these fractions. So what we're going to do is multiply through by a common denominator. That's going to be 2a times a plus 1. That's our common denominator if we're going to get everything as one big fraction. When we multiply through by both of these things, 2 times this stuff here just becomes 2 times 2a times a plus 1. Minus, when I multiply 2a times a plus 1 times this fraction, 5 over 2a, the 2a's are going to cancel out. So that just leaves me with 5 times a plus 1 equals, and when we multiply it over here, the a plus 1's are going to cancel out. And that just leaves you with 2a times 2a. Now we just got to multiply all the stuff together, get the quadratic looking guy, and simplify. So over here we're going to get 4a times a plus 1. That's 4a squared plus 4a. If you multiply all that out. Minus 5a minus 5 equals 4a squared. Now we're going to subtract off this 4a squared on the side. And what that gives us is 4a minus 5a minus 5 equals 0, which says negative a is equal to positive 5. You can simplify that down, which means a is negative 5. There you go.